Drainage water recycling is a practice where one would collect surface runoff and subsurface drainage discharge into a pond. That pond will then store the water temporarily as a reservoir for later use during the growing season.
The idea is going to be to keep every bit of water that falls on the farm, and it should leave in the form of a crop that leaves in a truck. There is possibly going to be some challenges there with the different weather patterns.
When it comes to managing water inflow and water outflow, a lot of that is tied to rainfall contributions. We're at the grace of God there. Outflow, we're primarily lifting that water up to our irrigation system, whether that be sub-irrigation, whether that's subsurface drip irrigation, or an overhead irrigation system. For our overhead irrigation system, we've been utilizing a Woodruff chart. For subsurface drip irrigation, we're doing a lot of evaluation on water sensors, to time irrigation events, and usually we're trying to apply based on water use. For a sub-irrigation system, we've been utilizing observation wells to monitor the water table depth. That allows us to see the water level in the soil profile above and then between the tile lines. And we leave it as high as possible throughout the growing season. Now, that makes it susceptible to saturated conditions if we get a lot of rainfall. So we have to be very responsive to when a rainfall event takes place, and it would need to be moved into drainage mode. Currently, that's manually changed, and it's a lot of work. And there's a lot of mechanized systems that are available, and that's one of the goals here at this site is to feature some of that new technology that we can tie a sensor in the soil to a automated system that can adjust our slides and the control structures, and ideally do that remotely.
For our drainage water recycling system, water that actually flows into the reservoir is not managed particularly in any strict fashion. Surface runoff and subsurface drainage are just allowed to actually flow into that reservoir as needed. Occasionally we'll have very large rainfall events that produce large volumes of runoff. In those particular cases, we actually have an overflow system on the reservoir. That overflow system allows excess water in that pond to actually outflow from the system and then drain into the ditch systems and the rivers nearby, just to try to maintain, again, that elevation of water in that pond. In addition to using sensors to monitor the stress of the crop through the temperature of the plant leaves themselves, we also use soil moisture sensing. We actually will go into our plots and we'll actually take soil moisture measurements on a weekly or bi-weekly basis, depending on the time of year. And we use that soil moisture content to be able to use what we call a checkbook method for determining how much plant available water is in the soil for the plant. When we reach a certain threshold, that's another way that we use to help indicate when we need to actually add supplemental irrigation water from our drainage water recycling sites. When we find the need to have to actually apply supplemental irrigation to our crops, we actually have a series of on-surface drip irrigation lines and manifolds that we actually will go in and add water to different areas of the plots at different points in time through our irrigation system. And also, depending on the threshold of where the crop is, how much need there is, we can actually adjust the timing of how long the irrigation happens, whether it happens early in the day, late in the day. Using an on-surface drip irrigation system like we're using is extremely efficient, and it also ends up putting water right in the zone near the surface where the highest density of roots are, so the plants can really take that water up quickly.
I think we add a lot more flexibility when it comes to crop management. The other thing is we add intensification. We can increase our plant populations on corn so that we can maximize yields. I think we've got better fertilizer utilization. A lot of times we have a yield goal that we're fertilizing for, and then water, either too much or not enough, is the real limiting factor. And so we're really eliminating one of those limiting factors, and so that we can maximize the utilization of those resources.